Here is another type of quadratic equation application question where you're given an equation in vertex form of a real-life situation. In this case, a flare is launched from a ship. Its height above the water at time t is given by the equation seen there. If you graph this, it would be in the shape of a parabola. It would open down because of the negative a value and would have a vertex at 486. This means that the flare would attain a maximum height of 86 when the time equaled 4 seconds after being launched. This is something that we did in our previous quadratics unit. Now we're going to do some more practice in addition to what we did in the quadratics functions unit. So the first thing that we want to do is find its height at the moment it was launched. At the moment it was launched is t equal to 0. So we're going to use the equation, but put in t equals to 0. So minus 5.25 minus 4 squared plus 86. When we evaluate that, we get 2 meters. The next thing we're going to do is find its height after 2 seconds. So now, same approach that we did in B, except now we're using t equals 2 instead of t equals 0. So here we've got h equals minus 5.25, and then we've got 2 minus 4 here, squared, plus 86. When we evaluate that, we would have that h is going to be equal to 65 meters. That you can do using your calculator. Part D is going to ask us how long it took until the flare hit the water. So the flare hitting the water is h equal to 0. So that means instead of substituting into the right-hand side, we're going to substitute into the left-hand side. So we've got t minus 4 squared plus 86. And now we're trying to solve for t. So we're going to unravel all the pieces of the equation. First thing that we're going to do is move 86 over to the left-hand side. And I'm also going to divide by the term in front of that quadratic. So minus 5.25. That is going to leave me with t minus 4 squared. So then I can evaluate this on my calculator and I get 16.38 plus some other stuff is going to be equal to t minus 4 squared. So now in order to eliminate that quadratic part, I'm going to take the square root of both sides, but when I take the square root, I'm going to get a positive and negative answer. So now the next part of my expression is I've got t minus 4, no square root because I undid that. On the other side, I've got plus or minus 16.38 and then a whole bunch of decimals. So the last thing that I have to do is move this 4 over to the right-hand side. So I've got t equals 4 plus root 16.38. And that is going to give me 2 answers for t. So I'm going to get t1, we'll call it, is approximately 8.05 seconds. And then my t2, my other solution, is minus 0.0472. This time is inadmissible because time has to be greater than 0. So therefore, it took 8.05 seconds to hit the water. Okay. Part E, now we're looking for how long, so time again, was the flare higher than 60 meters above the water. So we're looking for the range. So how long was the flare above that value? So we're going to use the same approach that we did in D. So substituting in our value on the left-hand side, and our equation is the same on the right-hand side. And we're going to follow the same approach that we did to isolate for t. So I'm going to subtract 86 and divide by minus 5.25 equals t minus 4 all squared. When I divide here, I'm going to get about 4.952 and some change. And then I've got t minus 4 squared. Again, I'm at the point where I'm going to take the square root of both sides. When you take the square root, you do get a positive and a negative value. So I've got t minus 4 is equal to plus or minus the root of 4.952. I can then move my minus 4 over, and I get that my answers for t are 4 plus or minus the root of 4.952 with those extra pieces on the end. This is going to give me two values for t. So I've got 1.77 and t2 is going to be 5.77. Now what I'm really looking for is my delta t, or my change in t, which is going to be t2 minus t1, which is going to tell me that the flare was above 60 meters for about 4 seconds. Okay, so let's draw a little picture there just to finish up. So I have my quadrants here. I've got time and height on my axes, and then I've got 2 times to plot. So I've got 1.77, and then I've got 5.77 here. Okay. I also know from the beginning here that my flare is going to hit the water at about 8 seconds, which is maybe over here. Okay. And then I know that my maximum height is at 4 seconds, so somewhere in the middle. Okay. Just labeling some points here for accuracy. And I know that at t equals 0, my height is 2 meters. So my parabola is doing something like this. Okay. What these 2 points here, the 1.77 and 5.6 show, is that if I go up here, this is at 60 meters. So I'm going to go across like this, and then I'm going to go down like this here. So that means this whole section that I've highlighted in red, the parabola, the flare, is above 60 meters. So that is a visual representation of the algebra that we did on the left side of the screen.